Hi, this is Nathan Tintle. In this Learning Goal video, we will discuss the advantages of a paired study design versus an independent groups design. We will use the rounding first base data to talk about this learning goal. In this data set, 22 runners ran from home plate to second base, taking a narrow angle at first base as well as taking a wide angle. The average time that it took runners with the narrow angle was 5.53 seconds, with the wide angle was 5.45 seconds, and we're curious, is this a significant difference? Now, the really key thing to keep in mind here is the researchers designed the study using pairing. That is, each runner ran both methods. Why is this? Well, some people are just faster than others. You'll see here, if you look at the red and the blue dot all the way to the right of your screen, someone took approximately 6.2 seconds to run using the two different methods. You'll notice that most people were fairly consistent in how long it took them to run. And so there's a lot of variability in people's running time. Some people are just naturally faster or slower than others. So if we're going to compare these two methods, it's very important to account for the fact that there's a lot of variation between different runners. So if we have the same runner run both methods, we can control for this extra variability of how fast are people inherently. This is really illustrated if we look at two different simulations. In the simulation on the left, you see simulations under the null hypothesis where you have a paired design. These values are values of the statistic, that is, how different are these two groups when you have a paired study design. That is, we have 22 runners and they run using both approaches. Here, the standard deviation, or the variability under the null hypothesis, is 0.025. Now contrast this to the standard deviation of the null distribution without pairing. So this would be equivalent to a study where we had 44 runners, 22 ran with the narrow angle, 22 ran with the wide angle. Here, the standard deviation is 0.085. In other words, the variability is quite a bit larger. Ultimately, what this means is that because of this excess variability in the null distribution, it's going to be quite a bit harder to say, oh, there's a significant difference between these methods without pairing. Why is that? Because of all this excess variability in people's run times. With a paired design, we control for that, we deal with that. That handling of that excess variability means there's reduced variability in the null distribution and ultimately helps us draw a better conclusion. Two words of caution. Pairing is a good idea when the values of the response variable tend to be similar within the pair. So for example here, running time within a person was fairly consistent, and so pairing made a lot of sense. If you recognize the person-to-person variability or whatever your pairs are, and you account for it by pairing in your study design, this ultimately reduces the variability in the null distribution. Said another way, the variability in the null distribution being reduced improves power. In other words, it improves the likelihood that you're going to find an effect if there actually is one. Less chance of making a type 2 error or having a missed opportunity.